We've heard a lot about pull requests in this day so far from, it's come up in almost every panel. A lot of us have probably known intuitively that pull requests have like a really critical impact on the overall health of our ability to do work as a dev team. LinearB Labs has some research on this that I'm going to show you that's really insightful. Let me start, though, by defining what it means to have a healthy pipeline. At LinearB, we tend to define this by, hopefully a lot of you have read the Accelerate book. As Accelerate has become more popular in the last few years, the DORA 4 metrics, which were discussed in detail in Accelerate, have become more popular. There's 4 DORA metrics. Cycle time, which is sometimes called lead time for changes in deployment frequency, are great metrics to show you the health of your speed in your development pipeline. Someone's going to be posting a link to a page that explains DORA metrics in more detail in the chat if you want to check that out. There's 2 metrics, change failure rate and mean time to restore, that are really good indicators of the quality of your development pipeline and the quality of work that your team puts out. So when we say pull request size is the most important leading indicator of a healthy development pipeline, we're using these 4 DORA metrics that measure speed and quality to define what we mean in this case by healthy. Now, it actually affects, pull request size affects other really important things that matter to your development pipeline, like the amount of time it takes for you to do pull request reviews. Again, this came up in some other sessions earlier. We have data that actually proves the effect that your review time has on your overall dev team, as well as a really important indicator of quality called code churn, which is how often you're rewriting code very quickly after you merge it. So PR size affects these 6 indicators of a healthy dev pipeline and even more, but we're going to talk about these 6. Let's get into this incredible research from LinearB Labs. And one of our incredible data scientists named Hadar pulled all this together. All the work that Hadar did that I'm going to share with you right now can be found at our overall benchmarks report, which you can get at linearbio.io/engineering-benchmarks. There's a ton of cool data in there. There's a blog that explains Hadar's methodology and everything we did around it and how you can use it. Okay, so let's start with this. First thing you need to know about why pull request size has a huge impact on your healthy dev pipeline is that pull request time makes up about 2/3 of the entire cycle time of the average dev organization. Cycle time in this context, in the DORA context, means the amount of time it takes from when you start committing code until when that code gets all the way through your process into production. For the average dev team, according to the 2,000 organizations and 26,000 devs and 700,000 pull requests that we reviewed, the average dev team has about an 8-day cycle time. And about 2/3 of that, 5.5 days of that 8 days, is spent waiting for PRs to be picked up by a teammate after they've been issued, and then doing the ping pong back and forth on actually reviewing that PR. So pull requests have a massive effect on your overall cycle time and development health. Now, that in and of itself is not a problem, except for one thing that we found in LinearB Labs when we analyzed these 733,000 pull requests is that half of all pull requests are idle for half the time. 1/3 of all pull requests are idle for more than 75% of the time. So go back to that number of an average 8-day cycle time and an average PR time of 5.5 days. That means half of all pull requests are just sitting there for 2.5 days. And 1/3 of all pull requests are sitting there for almost 4 days, just idle. No work happening on that. That is real trouble. And I'm going to explain why. So Dan Lines wrote a blog about this recently, about why this happens. He calls it the pull request paradox. Someone's probably putting a link to that blog in the chat right now. We all know as developers that we're like dependent on one another, whether it's pair programming or mob programming. Most of us use Git flow, so we're probably doing pull requests to help each other increase the quality of our code. And we all inherently know that we're dependent on one another, but there's still this conflict built in where I just came off 2 hours or an hour of great coding. I've solved this problem. And now in order for me to move on to the next thing I want to do and get my code merged, which is my priority as an individual developer, and it should be, merging my code fast is the number one thing I can do as an individual developer to speed up our overall team cycle time and project velocity. And the conflict is that I need your help. You're a developer on my team, but you're busy in your own zone. You're in your own zone and you are solving an important problem right now. And maybe it's not good for you to just stop. Now, when you're ready to look at my PR and maybe ask me questions or sync together real quick, I'm off doing something else. This is a huge problem, which is backed up by this research from LinearB Labs. Now, some people would say, what's the big deal? I issue my pull request. I move on to something else. And when my teammate is ready to ask me questions about it, if it's a few days later or whatever, it's no big deal. But that's actually not true. And you may remember Ben mentioning this from Stack Overflow in his session. So there's a couple different types of idle time that happen in pull requests. All of the handoffs from when I issue my PR and I'm waiting for you, from when you request changes and now you're waiting for me, I make the changes and now I'm waiting for you to approve. That creates the idle time. The problem with that is every minute that goes by after I write the code and then you ask me for changes, or you ask me for changes and I make the changes, it increases cognitive load, which hurts our ability to do the best job on getting the code right in that pull request. Reload time, which is what we call the amount of cognitive load time, leads to lower quality, and it actually leads to a lot of context switches. Now, there's this other kind of idle time we call distraction idle time. It's actually when the task is just sitting with us, there is still a chance that we could have cognitive reload time because, and this is where we get to PR size. If we have a large pull request that we have to look at, we may not be able to finish it in one sitting. I can't remember if it was Jenny that mentioned this. And so I'll tell you what happens to me. I start reading a pull request. I have a long idea how long it's going to take me to look at it. I get 15 minutes in and then I get pulled away. When I come back to that 2 hours later, the next morning, what happens? I don't get to just immediately pick up where I left off. I have to reread all of the code again. I actually have to reread my own comments that I may have already made in order to then finish. So we've really wasted a lot of time. And again, the reload time leads to lower quality because I'm not as engaged on what I'm doing as I was the day before. Luca brought up something in his session earlier in the day. Keep 90% of your pull requests below 200 lines of code. I don't know if he knew this. I don't think Luca saw an advanced copy of our research. But we've all, if we're trying to do agile, we know it's good to break work into small chunks and go faster and get faster feedback loop. The research that Hadar did from LinearB Labs proves that not only is smaller better, but there's a magic number of 200 lines of code, which Luca also intuitively knew. And there's proof of this. So look at this chart. It takes us twice as long to review PRs that are over 200 lines of code, even if they're only 600 lines of code all the way up to 1,200 lines of code. It takes us twice as long to review those than if the PR is 200 lines of code. And it takes us 3.5 times longer to review PRs that are 50 lines of code or more. And again, this comes from analyzing almost 4 million comments from 700K pull requests across those 26,000 developers. So this is proof that it's not just general agile best practices, keep the chunks of work smaller, The magic number is 200 lines of code. And here's another important reason why small PRs are a really important leading indicator of a healthy dev pipeline. There is actually an effect. The amount of time it takes for you to start working on a pull request has a direct correlation to the overall amount of time it takes you to finish the pull request. That correlation is not depicted in this slide, but you can see it in the research at LinearBio/engineering-metrics from Hadar. But what this shows is that one of the things we have in our WorkerBee developer workflow tool that Trong talked about earlier is we display the estimated review time for pull requests. And since doing that, what we have found is what, again, we all intuitively know, but now we have proof. If you have a small pull request, you are going to get your pull request picked up dramatically faster than if you have a big pull request with a 30 to 60 minute estimated time of review. And why does that matter? Because the faster we start working on a PR, the faster we'll finish it overall, and the higher the quality for that PR is going to be. Okay, so that's some of the research that kind of proves the impact of PR size. Now, let me explain how PR size directly affects those metrics I talked about earlier from Dora that are the indicators of whether or not our pipeline is healthy. So let's talk about the effect that PR size has on cycle time. So again, cycle time is the amount of time it takes us to get work through to customers from when we start committing code to when it's deployed to customers in production. PR size, and by the way, at LinearB, we break up cycle time into these 4 phases because cycle time is great for detecting if you have bottlenecks, and it's really great for detecting if you have bottlenecks if you break it into these phases, because then you can zoom in on any particular phases that need help. PR size affects all of the phases. So if you have high PR time, your coding time is going to be high. Coding time is the amount of time we spend on one chunk of work, right? If we keep our chunks of work to as small as possible, 200 lines of code or better, we are more likely to sit down in one sitting and do one chunk of work and then ship it off. Whereas if we're working on a bigger chunk of work, we're more likely to have distractions. When we come back to try to finish our pull request, we're going to have reload time. Even our initial coding is going to be degraded. You saw from the stat earlier, it affects pickup time. If you have a large PR size, it's going to take a lot longer to get picked up. And all that time that goes by is creating an increase in cognitive load. It reduces our situational awareness. That makes it harder for us to get through the review itself really well. And ultimately, it actually can have an effect on the deployment frequency as well, which we're going to look at next. So, a lot of us, to get a really strong CI/CD in place, rely on automation technology to do that. Deployment frequency in general, the amount of times, the frequency in which you release, it's highly dependent on PR size, right? You are almost unable to have what would be considered an elite deployment frequency if your average PR size is thousands of lines of code, because there's just so much more work that goes into getting that code ready, so much more testing, so much more time in the PR process that it just slows down your ability to do it, even if you have a great CI/CD automation technology implemented. So PR size really is critical to your speed. And as far as quality, it's arguably even more important, right? So change failure rate is the amount of incidents you have per release. You are going to have more incidents if you have bigger chunks of work going through into production. It's just a fact. And so big PR size equals higher change failure rate. Big PR size also takes you longer to roll back and fix incidents after you discover them, which is what mean time to restore measures. How quickly you fix incidents after you discover them If you have small chunks of code that are failing, you can roll them back, fix them, and re-release them faster. If you have big chunks of code, it's going to take you longer. So PR size, really critical to the quality, arguably more than things like test coverage or anything like that. I also talked about how PR size affects code churn. If you're not tracking code churn, it's a really, really important metric that you should be looking at. It's the amount of code you're rewriting by our LinearB definition within 21 days of when you initially merge. Code churn is a really good indicator of speed and quality. If you have a high code churn, you likely have a bad CFR and MTTR. You likely have slow cycle time. It affects your planning accuracy. If you're constantly rewriting code because you're not expecting to be rewriting that code, and low PRs reduce code churn because the small PRs are more likely to have a higher percentage of test coverage and better, more thorough PR reviews. And so the quality is likely going to be higher, and you're less likely to have to rewrite the code. Okay, so we all agree like small chunks of work is better, and in an ideal world, maybe we keep the PR sizes below 200 lines of code. How do we actually do that though? So when you are in the if you run Scrum or frankly Kanban and you're in the planning stages, individual developers can contribute to this by thinking about what their sitting time is, right? How long do they sit down and try to get in the zone before they get up, stretch out, take a break, get interrupted? And let's say that's 90 minutes. Those are what we want to shoot for when we're breaking works into small chunks. If we have big refactors, it's better, A, to break those into small chunks, and B, keep those in separate pull requests. If your way of measuring PR size and cycle time is intelligent enough, you'll be able to break those exceptions out and keep them in a separate swim lane for your metrics. So you're not measuring all of your big refactors in the same metrics you're using to measure your normal feature work. And then one really critical thing is to get buy-in on this from your developers. For example, we at LinearB use this concept called working agreements, where every individual Scrum team gets together and decides how they're going to work on things like PR size. And if the developers are bought into it up front, then there's a lot of other things you can do to help them be more successful on an ongoing basis. Connor, I can't see the clock, so feel free to come off mute and tell me how I'm doing on time.
You're doing great, Rocco. Don't worry.
Okay, cool. Here's another really important tip for pull requests in general. Not all PRs are created equal. Somebody brought up context earlier in the day at Interact. We treat all PRs as equal, and this is one of the foundational mistakes that hurts us. And there's a way we can solve this. If you have a very small, very mundane PR that you're sending out, we don't want to treat that the same as one that is related to a Jira issue that's related to a critical feature that a lot of customers are waiting for. PR reviewers will be able to they will be able to make a decision about your pull request better and faster if they have a lot of information about it. What percentage of test coverage, what issue in Jira or Clubhouse or whatever issue tracker we're using is it related to, right? Therefore, we know what feature or bug or hotfix it's related to. If we actually call out specific reviewers, one thing that our team tries to avoid is just dropping alerts for a new pull request in a team channel and not saying anything about that. Most of us are conditioned to ignore a lot of things in team channels if our name is not tagged on it. And then we really believe in this estimated review time thing, where one of the key decisions that the reviewer needs to make is, can I pick up this PR right now? And if not, when can I get it? And if they don't know how long it's going to take, they can't make a good decision on that. And those PRs are more likely to sit there for a long time. So add context to your PRs, because not our PRs are created equal. Another important thing that Hadar discovered in the LinearB Labs research is that your quality and speed for PR reviews improve dramatically if you can open and close it within the same working day or within a 24-hour period. So there's no more than one night in between when you open your PR and close your PR. Now I'm not saying obviously PRs that finish within one day finish within one day. What we're saying is that there's literally significantly more idle time built in to the PR time for PRs that span more than 24 hours. And so if you add a lot of context to your PRs when you post them for your teammates, and they know the ones that are more important, remember, don't treat all PRs as equal. When your teammates know which PRs are more important, you have the ability to post an important PR in the morning after 90-minute time of being in the zone. Try to find somebody to pick it up right away and make all the changes in the same day for your important PRs. If you do that, you will cut out idle time and increase the quality, not just the speed. Another thing that's a little controversial that we're doing at LinearB, that a lot of LinearB customers are doing as well, is we are going against the grain and saying that there is a middle ground between just not doing pull request reviews and between having to switch to do all pair programming or mob programming. We have this idea of a synchronous PR review. So we still code by ourselves, we still package up our PR and send it, but then we believe that not all context switches are bad, and that if you can find a reviewer and in real time be available to pair in the context of that PR, that will lead to good things. Now, more than likely, that means if you are the PR issuer, when someone is ready to look at your code, you have to drop whatever you're doing and make a context switch to be with them in that moment on their terms, not on your terms. Now, that may sound like that's a context switch and that's bad. We believe overall that that's a good context switch, and that overall you as a developer, by getting your PR merged faster, if you make yourself available to that reviewer in the moment then they're ready to talk to you, that overall by you'll get your work merged faster, and that will actually allow you to spend more time focused on coding and not get your work stuck. So a little bit against the grain, but something that is working for us and working for some LinearB customers. So we have a few ways we can help with this at LinearB. The first thing we do is that you can go right now to LinearB and get a free account of all of your DORA metrics, including cycle time. And you'll see it takes about 4 minutes. You'll see if you actually have a problem with your PR pickup time or your review time that you need to solve. We'll show you if that's a bottleneck. We'll actually show you your average PR size, so you know if your PR size is in that 200 to 500 range or if it's a lot higher. Then we automate the process for that working agreement process I described earlier. Don't do a top-down thing as a VP of engineering where you tell your leads and your developers, we're going to have all PRs at 200 lines of code. That's something that you can strive to over time. But what we find works better is use those benchmarks that are posted in the chat channel. See where you're at. And let's say that you're in rough shape in the column that needs improvement. Try to make a 1-tier improvement, and do that by getting every individual team together of developers, buy in on what the next level of improvement looks like for PR size. And we automate that for you in our working agreements area in the product and let you track your improvement on that. And then the most important thing we do is with our worker bee bot that Trong talked about earlier. Instead of you constantly having to remind your developers that they agreed to keep their PR requests small, we will actually use our bot that's for individual developers, that's for them, it's designed for them, to remind them of the working agreements that they agreed to give them that context I talked about, right? So we'll show you what the estimated review time is, what issue it's related to, so you know it feature or bug. We'll let you know if your team agreed that PRs should be reviewed within 2 days. We'll notify you when that's not happening. And then beyond pull requests, WorkerBee does all these other cool things to save developers time, help them merge faster, and spend more time coding. One of the cool things that developers love about WorkerBee is this thing we call one-click ticket, which you'll see at the bottom under automate annoying tasks. Developers would love if they didn't have to go into Jira, but we need to go into Jira to keep people up to date on our work. What if instead of doing that, you're a developer, you could just start your next chunk of work. LinearB will detect when you're working on something in Git that is not connected to a Jira ticket or an issue tracker ticket. We will ping you in Slack and write in Slack, let you attach your work to an existing ticket or create a new Jira ticket so you never have to leave and log into Jira. We have this mission for developers to never log into Jira again. We need Jira as a dev team, but it's not the most popular way for developers to log their changes. So WorkerBee helps with pull requests and a lot of other cool things as well. One of our customers, Illuminate, had great success doing this. They had this exact scenario. Their pickup time and review time were way higher than they wanted. They got together and each team came up with a working agreement around their average PR size and how long they wanted to finish, how quickly they wanted to finish reviews. And you can see when they implemented WorkerBee, their cycle time improved dramatically, which led to the CTO being able to observe that they were shipping more features faster, which is exciting. And the developers loved it because they were getting to merge their work faster and spend more time writing code. Another way that you can start this process of improving your PRs is with a free Chrome extension we have, where we give you a magic link for all your PRs right in your GitHub page, and it shows the estimated review time. You can add a fun little meme to it. We give a bunch of other context that helps, and we find that dev teams that use this free Chrome extension with the average review time, they're improving their pull request time and their overall cycle time by about 20% in just a few weeks. So check that out. And if I have any time left, then I'm going to take some questions.
We do have some time for questions here, Rocco. So I've just put one on screen. Someone asked, Brenda asked, are all of these stats included in the free version of LinearB, or do you need a license to get more insightful metrics?
All the 100, the door for metrics, as well as code churn, PR size, and some other really cool things like around team health, WIP, are all included in the LinearB free forever for teams of up to 8. And then I'm sure we've got some salespeople around here if anyone wants to learn what it takes to get a pro or an enterprise account.
Awesome. And then Mark actually asked, he loved your slides and is wondering if they could reuse the PR slides to educate and advocate the benefits identified by door metrics.
100%. And I'm sure that someone from our team would love to come into one of your meetings and help you with that. Hadar or a lot of members on the team are experts on this. So we can give you the slides. And if you want us to pop in for 10 minutes to help with context, let us know. I can personally coordinate that for you. I'm sure someone can share my email address.
Yeah, would be more than happy to. Let's see. Give me a second to find some more questions here. So here's a great one. Alyssa Johnson asks, do you have the data points to break these numbers out for greenfield development versus ongoing maintenance / development around the engineering benchmarks?
Yeah, not in the version that we just published, but that is on our radar. We actually, you might be able to meet with Hadar and convince her to show you the crosstab that has a lot of this data. We know the answers to a lot of that, just not fully vetted and published yet. So we're definitely working on breaking out all of these stats by team type, team size, issue type, and a lot of other things that we'll be publishing in the coming months.
Great. And for anyone who wants the Chrome extension, Rocco mentioned it is free on Google Chrome, WorkerBee for pull requests. What's in the chat right now, Jonathan, thank you for sharing that. Aiken Roberts asks, if there's a QA process after a PR has been reviewed and approved, can that skew metrics, and how do we handle that skew?
That didn't. Yeah, so we actually track that in LinearB, and didn't show that on my screenshots. But we have the ability to show more advanced cycle time breakdowns where we look at your post merge testing, manual QA, and what other phases you have in between merge and release. So you can see metrics on that in LinearB as well. And by the way, forget about LinearB for a second. If you have a significant amount of activity that happens after merge before you get to production, that will the smaller the chunks of work that are flowing through, the more likely it is that if you find something in that post-merge QA that you need to go back and get the developer's help with to fix because you found a usability problem or just a bug. If they have to fix a large chunk of work, the amount of time it takes for them to refamiliarize themselves with that code to fix one little part of it is significant. So again, even for QA and post-merge testing, there's a lot of benefits to small PRs.
Awesome. I'm going to try to get 2 more questions in. I know we're running a couple minutes behind here. Danny Harding asks, does WorkerBee work with GitLab, and do you have integration with other message platforms besides Slack?
Yeah, we work with MS Teams. WorkerBee works with MS Teams. Today, the Chrome extension is only for Chrome. We are working on
Brave browser, so any Chromium.
Yeah, we're working on other browsers, and we're working on other Git systems like GitLab and Bitbucket. So check back really soon on that.
And LinearB does connect to Git.
LinearB works with GitLab and Azure DevOps repos and Bitbucket. The Chrome extension specifically right now, just the Chrome extension right now works for GitHub and Chrome, but LinearB supports all of those other Git providers, communication providers, and we have other issue trackers that we work with as well.
Awesome. And one last question from David Fernandez, and then I think we'll have to pull to the next session, but Rocco will be in chat after that to answer any other questions folks that have that come up. So David asks, what about refactorings and migration? Those PRs could have thousands of lines of code.
Yeah, so first of all, our CEO, Ori, would say definitely keep, still ideal that you have the ability to break those big refactoring projects into small chunks. But the other thing that you can do is look at your metrics for those separately, which you do have the ability to do in LinearB, so that you are not, you can exclude those types of branches or big refactoring projects and focus on just the work that fits in your normal motion to build features or fix bugs. Awesome.
Thanks for an incredible presentation, Rocco. I'm going to pull you out here now, and we're going to head into the next session. Rocco will be around for the next hour or two. If anyone has questions, feel free to ask him. He'll be answering stuff in chat. And you can always reach out to him at rocco@linearb.io for anything else.